So we have show that theta is arctan 2 over x minus arctan 1 over x. Okay, so we have tangent alpha is opposite 2 over adjacent x. So alpha is arctan 2 over x. And we have tangent beta equals 1 over x, opposite over adjacent. So arctan 1 over x equals beta. So we know that theta is alpha minus beta. So we've got arctan 2 over x, minus arctan 1 over x. Hence or otherwise find the exact value of x for which theta is a max and justify. So we want d theta dx. So we have, for the derivative of arctan, we're going to have 1 over 1 plus 2 over x, and all of that squared. And this is like 2x to the negative 1, so we have to multiply by negative 2x to the negative 2. Then, same thing here, we're going to have 1 over 1 plus 1 over x squared, and then we have times, this is x to the negative 1, so negative x to the negative 2. All right, so if we write this a bit neater, we're going to have negative 2 over x squared over 1 plus 4 over x squared, and then minus, plus 1 over x squared over 1 plus 1 over x squared. Okay, so then this is like negative 2 over x squared, this. All right, same thing here. This is 1 over x squared, this. So this is going to equal negative 2 over x squared plus 4 plus 1 over x squared plus 1. So now we can just set this equal to 0, and we'd have negative 2 over, we'll have 1 over x squared plus 1 equals 2 over x squared plus 4, cross multiplying. And then we're going to have x squared equals 2, so x is plus or minus root 2, and we have to have the positive because it's a length. All right, so now if we want to justify, we have to find the second derivative. Okay, so if we've got, this is our first derivative, so let me write d theta dx here is negative 2 x squared plus 4 to the negative 1 plus x squared plus 1 to the negative 1. So we're going to have 2 when we multiply by negative 1, x squared plus 4 to the negative 2 times 2x. And then we're going to have minus x squared plus 1 to the negative 2 times 2x. And then we need to substitute in square root of 2. So we're going to have 2 square root of 2 squared is 2 plus 4 to the negative 2, 2 root 2. So this is a positive number. Minus, and then we're going to have 2 root 2 over 2 plus 1, 3 squared. All right, so this is 4 root 2 over 36 minus 2 root 2 over 9, which is 8. So this is less than 0. So that means it's concave down. So at x equals root 2 maximum. And also all of these times I'm finding the second derivative, you could just on either side of root 2, 1 and 2, substitute into the first derivative and show that it's changing sign, okay? So that would have been a smarter way to do some of these. Oh well, so now find the maximum value of theta. So we need to substitute in here root 2. So we've got arctan 2 over root 2 minus arctan 1 over root 2. Okay, so they must want you to use calculator here, even though it says without calculator. I don't know, because you can't do this. These are not exact values. So what I did was I did tangent of both sides here, okay? And then I went back to the geometry section where it's the compound angle identity. So we're using tan A plus B, well, it's minus B, equals tan A minus tan B over 1 plus tan A tan B. So I filled all this out, and you can take a look at that to see how they get x over x squared plus 2. So when we put in square root is x, square root 2 is x, we're going to have root 2 over 4. All right, PF is a man standing on horizontal ground at a distance x from the bottom of a vertical wall GE. So he looks at a picture AB on the wall. The angle BPA is theta. DA is A. D to B is B. And angle PDE is a right angle. Find the value of x for which tangent theta is a maximum. Given your answer in terms of A and B, justify this value of x, that this value of x does give a max. Okay, so we are going to have, similar to last time, so let's call that alpha. No, this will be beta, and this will be alpha. Okay. So we have tangent beta is B over x. Tangent alpha is A over x, so that we have beta is arctan B over x, and alpha is arctan A over x. And we know theta is beta minus alpha, which is arctan B over x minus arctan A over x. So then I was going to do just the derivative of theta, but they're talking about tangent theta. So if we do the tangent of both sides, we're going to have tangent theta equals, using the formula in the formula booklet, tangent, A minus B equals tangent A minus tangent B over 1 plus tan A tan B. So if we do tangent of arctangent, because this is A here, that's just going to be B over x minus tangent of b, which is arctangent a over x, so this is a over x. And then we want 1 plus tan a, tan b. So we're going to have tangent theta equals b minus a over x, and then 1 plus ab over x squared, and tangent theta is going to be b minus a over, distributing the x, we're going to have x plus ab over x. Okay, so if we rewrite this, b minus a over, and this is going to be, if we make this the same denominator, x squared plus ab over x, we have tangent theta equals b minus a multiplying by the denominator x over x squared plus ab. So now we can do the derivative, because they want when tangent theta, not theta, tangent theta is a maximum. So we're going to do quotient rule here. So we have x squared plus ab squared, x squared plus ab. So that's v times the derivative of u, which is b minus a, minus the derivative of v, which is 2x, and then times u, which is going to be x. So another x is x squared, b minus a. And we can factor out a b minus a, and then we're going to have x squared plus ab minus 2x squared. Okay, and then that is going to be ab minus x squared. And then that's all over x squared plus ab squared. So if we set that equal to 0, cross multiply, and then we'd have b minus a, which is just a constant. So that goes away when we would divide it. So ab equals x squared. So x is root ab, because we take the positive. Okay. Now we need the second derivative of tangent. Okay. All right, so we are doing the second derivative of tangent with respect to x. All right, so we're going to have on the denominator, we're using this one. X squared plus ab squared to the squared is to the fourth, and we start with v up top as well. All right, so v times the derivative of u, which is going to be, so this to here is a constant, it would cancel. But that, that to this is the coefficient. So we're going to have negative b minus a times 2x. All right, then from that we subtract b minus a, b minus x squared, and then times the derivative of v, which is 2x squared plus a b to the 1 times the inside 2x. Okay, so here we have b minus a, so we can factor that out. We also have a 2x we can factor out. We also have one, so one of these to factor out. And then on the inside, we're going to have another x squared plus ab. We need one more of those, and negative that. and then minus 2ab minus x squared. And then that's all over x squared plus ab to the fourth. So now we can cancel that out and leave a 3. So we're going to have 2xb minus a. So negative x squared minus ab minus 2ab plus x squared all over x squared plus ab cubed. This and this cancel. And we have negative 3ab over x squared plus ab cubed. Now, this is the second derivative. We want to justify that this value is a maximum. So when we substitute that in, square root of ab squared is ab plus ab cubed. So x equals square root ab. So that is going to be, so square root of ab. And then we're going to have, hold on, I'll just do this. So we're going to have negative 3ab squared plus 3 a squared b over 2ab cubed. And then if we distribute that, we're going to have negative 6 ab squared square root ab, and then plus 6 a squared b root ab over 8a cubed b cubed, right? All right, so maybe whatever. So if we pull it out 6ab, we're going to have, I'll do this term first, a square root b, ab, sorry, minus b square root ab over 8a cubed b cubed. Oh my goodness. So then divide by 2, the a's cancel here, the b's cancel here. Take this square root of ab out, and this is a minus b. Okay, so this is a positive because it's a square root. This is a positive because it's squared. This is a positive. But a minus b, remember all the way up here. See how a is less than b. If we do all the way down here, a smaller number minus a larger number, this is going to be less than 0. Finally, we know it's concave down. So x equals square root of ab is a max. All right, 15 for each of the functions f and g, determine whether it's even or odd. So remember, if it's even, when we substitute in negative x, we get out the function. And if it's odd, if we substitute in negative x and we get out negative the function, it's odd. Okay? So either way, we're substituting in negative x. So e to the negative x plus e to the negative x is going to be e to the negative x plus e to the positive x, which is our function even for f. G, we're going to have e to the negative x minus e to the negative x, which is e to the negative x minus e to the x. So if we look at negative g at x, that's negative e to the x minus e to the negative x, which is negative e to the x plus e to the negative x, which is what we have. So this is negative g at x, so that's odd. Find the stationary points, if any, and determine their nature. Okay, so for b, we need f prime. So that's e to the x plus e to the negative x, chain rule. So we're going to have e to the x minus e to the negative x. If we set that equal to 0, we're going to have e to the x equals e to the negative x, which is 1 over e to the x. And if we cross multiply by e to the x, we're going to have e to the x times e to the x, which is e to the 2x equals 1. I think you can just see it's just x equals 0. You could do the natural log of both sides. And then you get x is 0. Okay, so at x is 0, there's something going on. So instead of finding yet another second derivative, I'm just substituting in x equals -1 and x equals 1 into the first derivative, which is this thing, or even, yeah, that's fine. So we have e to the x minus 1 over e to the x. So if we do -1, we're going to have e to the -1 minus 1 over e to the -1, which is 1 over e minus e, which is a negative number. And then if we do 1, we're going to have e minus 1 over e, which is a positive number. So find the stationary points. Okay, so x equals 0 is a stationary point for f. We should probably find the coordinate. So f at 0 is 2. And this, because it's going negative gradient to positive, is a min. Okay, if we have g prime, we're going to have e to the x minus e to the negative x times -1. So that's e to the x plus e to the negative x. So we can set this equal to 0. So e to the x plus 1 over e to the x equals 0. So e to the x equals -1 over e to the x. So e to the 2x equals -1. There's no solution here. So no stationary points for g prime. All right, find any points of inflection. Okay, so if we have f double prime, we will have, using this up here again, e to the x minus e to the negative x times -1. And that's going to be plus e to the negative x. Now we know this is equal to g prime, okay? We just did that over here. This is never equal to 0, so no inflection points for f. And for g double prime, we're going to have e to the x using that one, plus e to the negative x times -1. So e to the x minus e to the negative x. Now this is equal to f prime. And we know that's equal to 0 at x equals 0. So if we do g prime at -1 and g prime at 1, so we have already done that. This is a negative down here. This is a negative number and a positive number. So this is a point of inflection here at x equals 0. And if we sub in g at 0, that's going to be 1 minus 1, which is 0. So because it changes concavity, it's a point of inflection.